Hello. What I wanted to do real quickly was, as you're reviewing your calculus before we head into the differential equation side of the course, I wanted to just give you, of course, you've got the review sheet in front of you with about 17 problems, just kind of help reminding you of some things related to differentiation and integration, because we need to be pretty good at those things moving through the differential equations material. But you've got the sheet, and it's my expectation that you'll work through those problems and kind of refresh and remember how things work. But I wanted to provide some help. Now, I guess I could have, and I will, provide a key for you so that you know what the right answers are. But I thought I would just create a little video here that might give you kind of some intermediate help without giving you the full answers. Just you might need a couple reminders on how to do something, and then you can just jump right in and do it. So the purpose of this video is just to go through each problem and just highlight what I think the important things to remember are, to do to solve the problem, and then hopefully you can just solve it from there. You won't even need to worry about looking at the key or going to other resources or references. So we'll see how this works, but here we go. So the first thing I've done here is I've put the main rules of differentiation right here. Okay, the product rule, the quotient rule, and the chain rule. Let's just talk a little bit about them for just a second. So let's look at the product rule. There's my real casual way of writing the derivative of fg, right? It might look more official this way, ddx of fg, but I like to write it like this, just easier to do. So you'll see me do that a lot in this course. So if I want to take the derivative of fg, as this says, there's my product rule right there, and hopefully you remember that. Same goes for the quotient rule. And then for the chain rule, right, we get a little more official, but remember the chain rule is something that we use when we're doing when we are differentiating a composed function, a function that has one function inside of it. And so you've got an inside and an outside function, and then the chain rule says, okay, take the derivative of the outside function, just leave the inside all by itself, all alone, and then finally take just the derivative of the inside and multiply those. That's the chain rule, and we use that a lot. So those are the rules related to the derivative side of the review. Let's now just go through each problem, and I've just written kind of what I think is the key point, maybe a key starting place with each of these problems. So number one, very simple. You pretty much just need to look at a derivative table to find that derivative. It's just basically a definition, and you should know that in this class, in differential equations, we work a lot with exponential functions and logarithms, so you need to be comfortable differentiating and integrating them. So number one, just look up the definition of that derivative and remember it from a table. Number two, you're actually going to use the chain rule. You got to identify the inside function and the outside function and then apply the chain rule. And number three, same thing. So I've gotten really lazy there and just call it the chain rule. One function is the inside function, the other function is the outside function. Number four, the derivative of the natural log function. Again, just see the derivative table for that. It's one you want to memorize and remember because we do it quite a bit. We use it a lot. Number five, you're just going to use the chain rule again. And the key with the chain rule, like I say, is to identify the inside and the outside function and then apply the rule at the appropriate time. Now starting in 6, we start mixing all these rules up. So 6, the first rule you're going to apply is the product rule, because the function as a whole, initially out of the box, is a product. Okay, and then you're going to apply the chain rule. Okay, so you'll be using a chain rule inside the product rule. Number 7, kind of the same deal, but you'll be starting with a quotient rule because it's the quotient, And then as you work through the quotient rule, you'll need to use a chain rule at one point and a product rule at another point. And then, of course, all of these you'll need to be simplifying. So get some practice at simplifying. Now, number 8 and number 9 look the same, right? You might be thinking they're the same problem, but number 8 is to remind you about the purpose of this notation. See the x there? That tells you that when you are differentiating, you treat x as a variable, so you apply all the derivative differentiation rules to x. Any other letters, I'm not using the word variable here, any other letters, or we'd call them parameters, but any of those other letters are going to be treated as constants. And we know how to differentiate a constant. It's just going to be 0. So that's what that is a reminder of. Now, number 9 is actually the better way of, well, it's another way of saying the same thing using this notation. See, when you see those little Greek kind of deltas, that's telling you you're finding the partial derivative, and you're finding it with respect to x. So again, any other letters are treated as constants. You only differentiate things with respect to x. 10 is the same thing, except it's the partial with respect to y. And then that gets us to number 11. And I believe that I need to add one in here. So 11, and I think I just need to change this. Not differentiate, but of course you're going to integrate. So number 11 should be super simple. You're just doing some integration, and you're going to use the simple basic power rule. All right. Now, number 12, again, you might look and say I've included the same problem, but what I want to highlight in number 12 is it's a dy there. So that means that means y is the variable. Anything else is treated as a constant. Okay, so watch out for that. Number 13, just going to ask you to go ahead and see the integral table for the actual integral of e to the x. Number 14, you're going to need to review u substitution. Number 15, another integral table. Just remember those two integrals, and just pay special attention that there should be an absolute value involved in that one. Number 16, integration by parts. Okay, so review that. You need to find the integral or find the integrate by parts. Let's just write that down real quick here. So the integral by parts is this kind of deal. What you do is you look at your integral and you break it up into two pieces, u and dv. All right. You assign something to be u and something to be dv. And then the antiderivative will be uv minus the integral of v du. And so you can break it up like that, and then you're working on this integral right there. So that's integration by parts formula. And number 17, you're going to use again a u substitution. You can start there. If that doesn't work, you might try parts. We'll put that in here. And then I think that covers pretty much all the main things we're going to use in this class. Now, I will say this. Every once in a while we need to integrate something by partial fractions. Right? Well, we don't integrate by partial fractions. We use partial fractions to change the integrand, and then we use the integral rules. But you might want to check up on partial fraction problems. And I would also say make sure you find, maybe in the back of one of your books, a good integral table and a good derivative table, differentiation table, just to have as a reference.